Welcome, everybody. We are live. It is Thursday. It is almost Friday. I hope your week has been going well. I hope you guys are doing well and are in good health. I hope. I hope if you're working in the tech space. I hope nothing bad happens or no bad updates get pushed out and which have you make to work late. We're going to put that in the universe early. So like I said, but welcome back. We are doing this is day 16 of the Appsec Rabbit Hole, and we are live at the Alpha Esports and Technology Center. We are live on. I'm sorry, I'm drawing a blank. There was just a whole bunch going on, but we are live on YouTube, Facebook, Twitch, and LinkedIn. So shout out to everybody watching wherever you're watching. We appreciate the love and support. Um, what's going on? Anything? Anybody? So, like I said, hey, what's going on, Ty? So yeah, man, it's been for me, like I said, it's cool, but I got a busy weekend ahead of me. We got two esports matches. So we got one esports match on Friday. We have another esports match on Saturday. I also have to go down to Atlanta on Saturday. I have to go. Yeah, it's gonna be a crazy weekend. So although it is Friday, it is also not it's not going to be that much of a weekend for me, but hey, that's what it is. It's the life we chose to be to get to that next level and be successful. So I'm not complaining too much, and if I am, y'all don't have to listen. So let's see, give me 1 second here. I just want to clear a couple things because oh my gosh, why is it being so problematic for me today? Why are you being so problematic for me? I don't know what's going on. Sorry, y'all. Having having some technical difficulties over here. I feel like we should just be able to. Yeah, I don't know what's going on. All right, whatever. So, where did we leave off when Tuesday, right? So Tuesday we were covering the OWASP Top 10, which are the top 10 web vulnerabilities, web application vulnerabilities. OWASP is also known as what the heck is going on? All right, so I don't know it's one of the, what, it's like I said, oh yeah, I want to hurry up and get this. I want to get on here, and I got through work and got everything, and of course now it's like things want to act up. So anyway, OWASP stands for the Open Web Application Security Project, and they're an organization. They're a nonprofit, actually. They're a nonprofit organization that basically is dedicated to finding and releasing the top vulnerabilities that face applications. So web applications, mobile applications, APIs, cloud applications, serverless applications. I know they have some stuff with AI now. So they offer that, and they also offer training and do talks and presentations. Also, you know what? Fine, honestly, hey, OWASP, if you guys ever need a speaker, just let me know. So we were covering the top 10 list. We actually got through more than half of the top 10. I think we got to number 7 on Tuesday. So now we have 3 left. We have number 8, 9, and 10. So just to recap, we have, let's share my screen. Let's share my screen. Like I said, it's one of those days. So we covered number 1, which is broken access control, which is basically anything that allows you to gain access in an unauthorized fashion, whether you're able to elevate your privileges or you're able to bypass security protocols or passwords. Then you have broken. That one of the most popular broken access control vulnerabilities is known as insecure direct object references, or IDORs. That is number 1 because it's by far uh, really common, most common in apps today, but it's also really, really easy to do. Sometimes it's just a matter of iterating, going up or down a number or letter or what have you. Number 2 is cryptographic failures. So this is a weakness in encryption, or using, not properly configuring your encryption. Then we kind of went through. The different types of encryption. So you have data in transit and data at rest. So you want to make sure that your applications are encrypting your network information when the data is traveling from client to server. When you're browsing, you want to make sure that all that data that's being transmitted is encrypted. And then also when it gets to its destination, whether it gets to the server or it gets back to the host, you want to make sure that is also encrypted at rest. So that's cryptographic failures. Number 3 is injection. So this is things like SQL injection or command injection, where you can use code or commands to manipulate the application to speak to the back end and get information. You can dump databases. You can bypass security, gain access to the systems, what have you. Injection or SQL injection used to be number 1, but now it's dropped to number 3. Number 4, you have insecure design. So this is basically, when from the beginning or of that development of the application or the update or what have you, it wasn't designed with. It may have not been designed with security in mind, or it may not have been, thoroughly thought out. Where are we? Number 5, you have security misconfigurations. So this is when you're dealing with you're dealing with other misconfigurations in the security. So in the example they gave, there was like a Python console that allowed you to make commands to the operating system, right? The misconfiguration there is that it should not be able to do that. You should not be able to speak to the operating system and get those responses that you're looking for. Then you have number 6, vulnerable or outdated components. This is when you're using when you're using your operating system, or you're using your server, your application, or whatever component you're using, and you haven't updated it. So you're using an old version of it. So in the example they gave us, there was a web application that wasn't updated. We were able to find the vulnerability, and because of that vulnerability, we not only were able to get into the front end and log into the system, but on the back end, we were able to access the server and get more information. Number 7 is identification and authentication failures. So this is trying to remember what we did here. So this is where you're using brute force attack, or maybe the system is configured with weak credentials or weak permissions um, on the system that allow you to either guess the password, bypass it, or bypass the security checks. Again, that can also be considered a security misconfiguration, but um, like I said, it had but identification and authentication failures is that. So now we're going to look at software and data integrity. And then we'll look at number 9, which is security logging and monitoring. And then last, for number 10, we're looking at server-side request forgery, or SSRF. Okay, so software and integrity. When we talk about integrity, when every basically, let's back up. When you talk about integrity, you think of the CIA triad, right? And I'm not talking about the government CIA. I'm talking about basically the three pillars of cybersecurity. CIA. You have your confidentiality, you have your integrity, and you have your availability. So confidentiality, the concept of confidentiality is that anything that's supposed to be a secret or protected, remains secret or protected. Anything that has the concept of integrity means basically the way, however the file was, or however the file was intended to be, is how it should be at all times, unless it's supposed to change. And then even then, that's what's supposed to happen. And then availability is if a system is if a system is supposed to be available, then the system needs to be available. So let's give a couple of examples, right? So confidentiality, let's say again, you have files and folders that are specific to a user, or they're sensitive files and folders. If an attacker were to gain access to that system, and now they're able to dump those sensitive files, or any data breach that you've seen ever, that's a break in the confidentiality, right? Integrity. The concept of integrity is, let's say I send a file to Ty. However, when the file that I sent to Ty, halfway there, gets manipulated and Ty gets a different message, right? Then the integrity of that is broken, right? And you can test that by doing like hashes and things like that. So if you do a cryptographic hash on a message or an email or something like that, and then when Ty checks that hash versus the hash that he has, it's supposed to match. If it matches, then you know that the integrity is intact. And then lastly is availability. So in the event of a denial of service attack, or a server going down, that will affect the availability of that data or that system. So that's the CIA triad. So now when they're talking about software and data integrity, you'll see what they're going to be referring to, the fact that the software or the data should stay intact the way it's supposed to be, and there should be protections in place to maintain that the integrity is intact. All right, so TryHackMe says, when talking about integrity, they're referring to the capacity they have to ascertain that a piece of data remains unmodified. Integrity is essential to cybersecurity, as we care about maintaining important data free from unwanted or malicious modifications. For example, let's say you're downloading the latest installer for an application. How can you be sure that you're downloading it if it wasn't modified in transit, or somehow got damaged by a transmission error? To overcome the problem, you would use a hash, or you would see a hash that was sent alongside a file, so that you can prove that the file you downloaded kept its integrity and wasn't modified in transit. A hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading hashing algorithms, you'll often read about MD5 SHA, SHA-256, and many others. Let's take a look. Let's take WinSCP as an example to understand how better we can use hashes to check a file's integrity. If you go to their SourceForge repository, you'll see that for each file to download, there are some hashes published along. So here you'll see, here's a file, here's the setup exe executable file, but these are the hashes. So then when you download those hashes, when you download the file, you should check those hashes and make sure the hashes match. So if you remember when we set up our Linux box, when I got new SSH keys, to confirm it, I made sure that we checked the hash and confirmed that the hashes were different, right? So in that case, I wanted it to be modified. I wanted the integrity of it to be modified, because I actually didn't want to use the same SSH keys that came with the system. So I changed the SSH keys, but then I compared the hashes from the new files, compared them to the old files that came with the system to make sure that they were indeed different. Okay. So now they're talking about software integrity failures. So it says, suppose you have a website that uses third-party libraries that are stored in some external servers that are out of your control. While this may sound a bit strange, this is actually somewhat common practice. Um, Sometimes you'll have, you'll have components or elements of your website that you control but you don't control, right? So but you have their software library included because it might add it because it provides an added feature. It might provide some added convenience, right? So you don't necessarily control what's in that library. You grab that library from that other resource and include it into your code to make sure that whatever feature or whatever add-on you're trying to have on your application is there. All right. All right, so it says, take example jQuery, a commonly used JavaScript library. If you want, you can include jQuery in your website directly from their servers without actually downloading it by including the following line in the HTML code. So here you see the script source, and they reference code.jquery.com, and then is jQuery 3.6.1, right? So the problem is that if an attacker were to hack into the jQuery repository, they could actually change the contents of that file to inject malicious code. So again, they're not hacking you per se, or they're not hacking you directly, right? They're using that third party, or even in essence a supply chain attack. So if I know you're using a specific library and I can add malicious code to that library, then because you already trust that library to be in your system or on your application, you're not going to do the due diligence and checks because you already did that. You did that when you first added that library to your code repository. At least you were supposed to, I should say. But what happens is if I inject malicious code into that, any not just you, but anybody who is using that library will now be affected by whatever malicious code I put in there, right? So think of it like think of it like no, I mean it's like, yeah, think of it like an app, right? Like you go and you download an app from your app store, whether it's the Apple Store or Google Apps or whatever. Um, and you download the app, and it says, "Hey, do you accept all of these terms and conditions and all of that?" You click yes, and you're trusting the app. That's you basically saying, "I trust this app to run on my system, run on my phone, run on my device." If I were to now be able to access the app from the app side and add malicious code to that app, now whenever you use that app, my malicious code is automatically getting added to your device because you've already trusted the app. So that's essentially what they're talking about there. All right. So now it says it wants us to correct way to insert the library into your HTML code would be to use an SRI and include an integrity hash so that if somehow an attacker were to modify the library, any client navigating through your website won't execute the modified version. So this is the correct way to code that, right? So here you just see it is referencing the source of the code jQuery.com, right? It's just referencing that. To do it securely or to do it the proper way, you're going to have that same source, right? So that source there, but now you're going to have this variable for the integrity hat for the integrity, and what is doing is it's going to check this hash. Okay, so it's going to check this hash. So now, anytime that library is called, or anytime that library is basically activated, it's going to check to make sure that it matches this hash. And if at any given time it does not match, then you'll have an error, it'll crash, whatever the case may be, but you won't, it'll protect you. Okay, so it says what is the SHA-256 hash. So it says go to this hash generator, and we'll go SHA-256, and it says what is the SHA here. So we'll go here, we'll share this screen, we will put this in, and it said SHA-256, right? Yep, SHA-256 hash. So now we'll come back and we'll run the hash, and now we have our hash. So now we'll just copy this, come back over here, we'll share this back, and we will paste, we'll hit enter, and we are good. Okay. So that is software integrity failures. So now data integrity failures it's very similar to software, right? So TryHackMe says, let's think of how web applications maintain sessions. Usually when a user logs into the application, they're given some sort of session token, right? So this can be a cookie, a JSON web token, it could be whatever, right? But those session tokens are what tells the application that you're authenticated and you're logged into a session. Okay, so cookies are key value pairs of a web application that a web application will store on the user's browser and be automatically repeated on each request that the website is issued. Okay, so it says, for example, let's say you're creating a webmail application, you can assign a cookie to each user after logging in that contains their username. In subsequent requests, your browser will always send your username in the cookie so that the web application knows what user is connected. This would be a terrible idea security-wise because, as they mentioned, cookies are stored in the user's browser. So if a user were to tamper with the cookie and change the username, they could potentially impersonate someone else and read their emails. Again, well, I'm not going to say that. This application will suffer from a data integrity failure as it trusts the data that the attacker can tamper with. So it says the solution to use an integrity mechanism to guarantee the cookie hasn't been altered. To avoid reinventing the wheel, we can use some token implementations that would allow you, with all the cryptography, to provide proof of integrity without you having to bother it. And this is what I was talking about before with JWTs, or JSON Web Tokens. So JWTs, or JSON Web Tokens, are simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. The idea is that you can generate the token that you can give your user with the certainty that they won't be able to alter the key value pair with the integrity check. The structure of the JWT is three parts. There's usually a header, a payload, and a signature. Okay, so the header usually holds like metadata. So this is like the and the signing algorithm. So the payload contains the key value pair of the data, right? So that would have your username and when that expires, and then you have your signature is similar to the hash, and it's taken to verify that integrity of the payload. So now if you change the payload in any way, the web application can verify that the signature won't match, right? So this is your signature. If the signature were to change, then in theory, it would check that and have a problem. However, if this isn't configured properly, there are ways to manipulate that, right? Like that's something we'll get into later. I don't want to take up too much time today. Okay, so it says, notice that each of the three parts is simply plain text encoded with base 64. You can use this tool to encode and decode base 64. Try decoding the header and the payload of the following token. So we'll just grab this here. And we'll switch. and then we'll paste, and then we'll decode, and then we'll paste. Oh, did it fail to execute? Let's come back here. Did I grab everything? Try decoding the header and payload of the following token. Okay, so I did the signature too. So let's just copy those two, and now we'll come back. And now here you see we decoded it. I'm sorry, we pasted the header, and then we also pasted the payload. So you'll see that they're separated by a period or a dot, right? So you have the header dot, payload dot, and then the signature would go at the end. But here you can see the header and the payload. It tells you it's a JSON web token. It's using the hashing algorithm of HS256. The username, this is the guess, and then it expires here. Okay. Okay. So again, just to kind of break it down, you'll see the header tells you the type, so JSON web token. The hashing algorithm is HS256, which is also HMAC with SHA-256. Then you have your username, which is your guess, and then your expiration, and this is whatever time, however it's sorted out. Okay. Now, data integrity failures. How data integrity failures work is that you can actually, if you can manipulate certain things on that header or in that payload, you'll be able to pass that JSON web token, and the application would accept it, right? So, for example, they're talking about JSON web tokens in the none algorithm. So it says a data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. As we have seen, JWTs implement a signature to validate the integrity of the payload. And the vulnerable libraries were allowed attackers to bypass the signature validation by changing two of the things in the JSON web token. They modified the header so that the algorithm header would have a value of none, and then they removed the signature part. So they got rid of the signature, and then they changed the algorithm to none. Okay. So it says, taking the JWT from before as example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and payload, modify them as needed, and then encode them back. So here you see they changed that HS256 and they changed that to none. And then in the payload, rather than guest, they changed that to admin. Try logging into the application as a guest. Oh, I gotta create. Hold on. What application? Oh yeah. So I have to. Let's start our attack box and wait for that to load up. So and then what the other thing you can do is you can check. So most times they'll have these protected, but they won't. But there's other ways you can bypass it, right? So for example, you see the none, right, and you see it's all lowercase. But let's say their access control list or their access and deny list have none, just like this. But what if you did it in all caps? Or what if you alternated letters, right? So if you did uppercase N, lowercase o, uppercase N, lowercase e, or uppercase or lowercase N, uppercase o, lowercase n, upper. You know what I'm saying? What if you switched the case stuff around? What if you change that around? Are you able to bypass it then? And believe it or not, that is a thing. Okay, so when we get into here, like I said, we're gonna use the developer tools in the browser to see the JSON web token and everything. All right, so we are going to go ahead and fire up Firefox. And we should be getting an IP address shortly. Oh man, it looks like it wants to rain. All right, 37 seconds. What's the plans for the what was everybody's plans for this weekend? Yo, LA is getting mollywopped. I'm watching day one of the Call of Duty major in Texas. And LA, the number one team, is getting spanked. 144 at 233. All right, so it says unable to connect, and that's because we need to go to port. They said port 89. Yep. 8089. Unable to connect. 10.10.144.233. Oh, that's because this is HTTPS. We don't want HTTPS, we want HTTP. There we go. So now it says navigate and follow the instructions. Okay, log in to the application as guest. And what is the guest account password? So we will come here. Let's grab this over here. So is it? Hold on. So we have. All right. It sounds pretty simple. Blah 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 blah. I'm just looking to see if they gave us a password. Try logging into the application as guest. What's the guest account password? I don't know. You know what? Let's just guess. Guest. Hello, guest. Yep. So that was the password because we guessed it. We guessed the guest password. Okay, if your login was successful, you should now have a JSON web token stored in your browser. So now if we go, let's bring this up a little. And now we'll go here we'll click storage, and we should have a JSON web token right here. Let me copy it. Okay, hold on. So if it says if your login was successful, you should have a JSON web token in your browser. So we did that, and then go on your browser. You'll see the following tabs. Sure. What is the name of the website's cookie containing the JSON web token? So that was jwt.session. Learn how to spell session. Okay. Now it says using the knowledge we gained in this task, Modify the JSON web token so it thinks you're the user admin. So now we just need to grab our token. Okay, now we'll copy our token. We'll move over here to our generator. We'll close this and we will, oh, that's right. We have our signature. So we have our first dot. We have our second dot. Let's go ahead and get rid of that. All right, so now what we want to do is, let's do this real quick. I want to grab this signature back. So we'll cut it. Go here. Now we want to change the username to admin. Oh boy. So let's do this. Oh crap. Come on. Think, Davin. Cut. Close. Now I'm going to take this, copy this, close this, put this in here.
It's also a map that Boston had plenty of reps on as well. So certainly the hard point advantage are leaning towards LAPs, but in the Hacienda is one they definitely were wanting to win. And now Boston got hey, we get one of our best hard point maps in this series where we have an advantage. They didn't play with no fear in their hearts. They have nothing.
You know what? You know what? I'm an idiot. I'm copying and pasting the same thing because it's not going in the clipboard.
Not the best run up towards the major for Boston, but right now, lands absolutely.
I'm a moron, y'all. I'm a moron.
He was the difference maker. Way ahead of rotations, massive individual fights.
I'm a moron, y'all.
You can just see the brain operating for Bird, and he's able to play on the map. That's what the especially is a standout mode.
And that's probably what happened last night too, or the other night. I'm an idiot. I'm a goofy. So I've been so when you copy and paste from here to here, usually you don't have to use the clipboard. But because I copied from my browser over, see if I should have did it all in here, but because I used my browser to do it, I was supposed to put it in the clipboard. Guys, I'm sorry. I'm sorry. This whole time I'm sitting here going, what is happening? What is the problem? And that's what happened the other night. I guarantee you that's what happened the other night. So we probably wasted like 30 minutes. Oh, geez. All right. But that's how that's JWT manipulation. So y'all, I had me questioning myself. I'm sitting there going, I know I'm doing it right. And I was copying and pasting the same JSON web token. So I was copying the JSON web token, deleting it, and then pasting it right back because I didn't use the clipboard. Oh gosh. All right. Jeez. All right. So security logging and monitoring failure. So basically, this is just like if there's if your logging systems aren't catching the alerts, uh, your SOC team missed some stuff, or like I said, your SIEM tool isn't picking up things. That's essentially logging and monitoring. Okay, so when applications are set up, every action performed by the user should be logged. Logging is important because in the event of an incident, the attacker's activities can be traced. Once their actions are traced, their risk and impact can be determined. Without logging, there's no way to tell what actions were performed by an attacker if they gain access. If you don't have proper logging and monitoring, that could lead to regulatory issues. So that's fines or actions. So like you might be non-compliant with like PCI and HIPAA and SOC 2 and stuff like that. And then also, if you don't have logging and monitoring, how are you going to protect yourself from any future attacks? Okay, so information that should be used in logs are status codes, timestamps, usernames, if there's any API endpoints or page locations, and then and IP addresses. Okay, so the logs, some logs do have sensitive information, so you want to make sure that those logs are secured and stored properly, and that they are in a safe location. Okay. As you may have noticed, logging is more important after a breach or incident has occurred. The ideal case is to have monitoring in place to detect any suspicious activity. The aim of detecting the suspicious activity is to either stop the attacker completely or reduce the impact that they've made if their presence has been detected much later than anticipated. Common examples of suspicious activity might be multiple unauthorized attempts, requests for anomalous IP addresses or locations, not for from yeah use of automated tools. Particular automated tooling can be easily identified using the value of the user agent headers and the speed of the request, or other common payloads. Like in web applications, it's common for attackers to use known payloads. So like for example, if they're trying to test for SQL injection, you might see a single quote or a tick, right? If you see the cross-site scripting, you might see those script tags. If it's what's the other one I'm thinking of? If it's directory traversal, you might see something like a dot dot slash or something like that. So if you look at that, if you see that information, those are common payloads. All right, so it says what IP address is the attacker using? So we downloaded a file here. So let's go ahead and check these logs. We'll share. Oh boy. We'll check here. So here are the login logs. You see 200 okay, 200 okay, 200 okay, and then here's some 401 unauthorized. So this looks like it's regular traffic, right? Right? It's random. It's regular traffic because they're coming from different sources. 12.55, 14, 17, 99, 12, 67, 34, 34, 55, right? And as you look, they're all okay. So that tells you that more than likely these are legitimate logins. But now you start to see someone trying to log in several times from and they're unauthorized. You're getting a 401. And you'll see 49.99.13, 49.99.13, 49.99.13, right? And they're trying to log in, right? And then also look at the timestamps. Let's try this again. Everything is just kind of going cuckoo today. All right. Also look at the timestamps. Right? 8:15, 8:20, 8:25, 8:30. So every 5 minutes, this person is trying to log in. So what this tells me is that someone's trying to log in and they're waiting every 5 minutes to make sure that it looks random enough, or that the timeout doesn't get triggered, right? So if you log in, if you fail to log in too many times within a certain time frame, it'll lock out that user. So what this looks like to me is that whoever's trying to log in logged in with the admin, got a 401 unauthorized, and then they waited 5 minutes in hopes that the timeout is 5 minutes, and then they logged in again, and then they waited, and then they logged in again, and then they waited, and then they tried again. So that's what that tells me. So let's go back to our TryHackMe screen. So now it's asking for the IP address of the attacker, and that is 4999.13.16. 4999.13.16. And then what kind of attack is being carried out? That would be a brute force attack. Okay. All right. Number 10, server side request forgery. So remember what I was telling you guys before. This particular vulnerability, when it first came out, I understood the concept, but I struggled with the practical, so to speak. So I understood that, basically what ends up happening with server side request forgery is that you're making a request to a third party server, usually a server that you control, and to get that information, right? So you said you could set up a server, you could set up nothing crazy. You set up a simple server, and you're able to add that into the web request and get information. Okay, so I understood that, but it for whatever reason it wouldn't click on the practical side. Like I said, it took a while for me to understand it. So, okay, server-side request forwarding. It says this type of vulnerability occurs when an attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the contents of the request itself. SSRF vulnerabilities often rise from implementations where a web application uses a third-party service. Think, for example, of a web application that uses an external API to send an SMS notification to its clients. For each email, the website needs to make a request to the SMS provider's server to send the content of the message to be sent. Since the SMS provider charges per message, if they require you to add a secret key, which they pre-assign to you. To each request you make to their API, the API key serves as an authentication token that allows the provider to know to whom to bill each message. So here's a quick diagram. So you see the URL, my site, SMS server, and the server is server3sms.thm, and the message is hello. Then it gets that request, and then it sends that query to server3sms.thm and to the API, and it says send this message hello. Okay, so now from here, that query gets sent to that server3sms.thm. Okay, so what happens is the application exposes that server information or that server parameter to the users, which defines the server name of the SMS provider, which was that server3sms.thm. Your web application could happily forward the SMS to the attacker instead of the provider. So as part of the forwarded message, the attacker would obtain the API key, and that would allow them to use that SMS service provider to send messages and have you pay for it. So basically what happens is instead of the SMS server being server3.sms, the attacker changes it to a server equals attacker.thm. Hold on, y'all. All right. Okay. So basically, that is essentially what happens with a server-side request forgery. So now, from the user's attack box, they're setting up. That's crazy. Okay, so now they set up a netcat listener, and then when they set up the netcat listener, any request that gets sent, now you see they're getting the contents of of those requests. Okay, so here is it tells us to go to port 8087. Crazy, LA's in the losers bracket. All right. It says after exploring a bit, you should see an admin area. So we're gonna go ahead. Let's close this. Um, so we'll go to the admin area. Admin interface only available from localhost. Okay. Follow the instructions. Okay. Explore the website. What is the only host allowed to access the admin area? So it says localhost, right? Local host. I feel like I got like a stinger in my neck. Oh, jeez. Okay. Check the download resume button and where the parameters go. So let's back up. So we'll go home. We click download resume, and now it says file root PDF. So it goes to file. Okay, here we go. File root down. Check the download. Where does the server parameter point to? That looks like it's too many letters. That's because we're looking in the wrong place. Right, so it says where does the server parameter point to? So we'll dismiss that, and we'll go ahead and go back to our inspect element. Let's bring this up. Come back here.
What's going on through your head trying to get that final hard point in those last few seconds? Yeah, I mean, coming into this match when you was going to be a close game, it's a great team. But we just discussed it like ourselves, played our game. Second pose, just bring the confidence and just holding on.
Wrong site. Thank you. All right, so now let's go here. We'll hit the download resume. Inspect again.
It's been a while since the EWC, and I can tell right now that we're just really close friends. We go out together, we just do stuff, So it's pretty happy to be able to get this win with this team.
Y'all are getting on my nerves.
So that's all that matters. And yeah, we're gonna keep bringing the energy and hopefully
put in download.
You got a lot of fans out here. You got a lot of fans across the country. Talk to them. Let them know how you feel about it. Yeah, I mean, thank you guys so much for the support. I know it's been a tough year, last year too, but it doesn't matter. We learn from it. And thank you so much for the comunidad.
Okay, let's look.
Los quiero mucho. Gracias a mi familia en México. Gracias. Los quiero. Y a mi mamá también. Saki. Yeah, thank you so much, guys. All right, that's gonna do it for me and Snoopy on the stage. Croc Bucket, take us away.
Okay. Oh, that's why.
Snoopy dominating one.
Oh, geez. Come on.
In this matchup, you have number 8. That's right, David.
Okay, hidden section.
We have to go right into our scuff play of the game because this is the end. Boston Breach sealing the deal. It's tied.
Page content.
Yeah, so at the end of the game here, we saw a couple of it on this hill in particular where they just kind of played from the next hill side and just try to like get a pick on LEDs and just keep them off the hill, and it's just back and forth. And you're looking at the score, you're like, okay, we just have to make sure that they can win on this hill and secure rotation. So we're gonna throw just enough bodies.
All right, so I was looking for it there, but we'll just do this. So
you're the one guy. If you get a kill on rotation, it's gonna alleviate the full pressure. You see, he finds the first.
I was trying to find it in here. There it is, right here. Okay, I was trying to find it here so y'all can see it here. But you can hover over it and get it as well. But I wanted to grab it from here. So it looks, so it says the
character I've always heard about but haven't witnessed.
Bro, listen, Giga came out in full force. 44 kills.
check the download resume button. So again, we're going to make sure that we copy and paste.
Let's take a look at the bracket for Boston. What does it look like from here? Guaranteed top 6. This was your
So it says,
victory in any of our minors or majors. They are now looking like they're meeting up.
where does the server parameter point to? Secure file storage.com. Securefilestorage.com. Hold on, y'all. Sorry, y'all. I'm back. Okay, so now it says we need to make the request. So what we're going to do now is we need to change the information and give it our information. Okay? Oh boy. So now we see it says here the secure file storage is 8087, ID is 75482342. So what we're going to do is we're going to change that information to reflect our server. Oh my gosh. All right, so in order to do that, sorry, I had to get a little frustrated, just a little frustrated, just a little bit, frustrated. All right, so we're gonna give it our IP address. Sorry, y'all. All right, so here we're gonna actually do that in here. So secure file storage. So we're gonna say 10 dot, what is our IP address? 10.189.192. All right, and now we're going to say netcat LVP 8087. All right.
Trying to avoid the curse that is plaguing Allen, Texas. They are the higher seed in this fight. On the other
So
side,
now we're going to go here. Ooh.
I just think they have like a couple key pieces that always deliver in the big moments on the very big.
All right, so now we're going to go back to our web browser.
It has been 2 years in a row where he's been able to do so.
We're going to hit paste. We're actually going to get rid of that. Stop. We're going to get rid of that quote there, and that quote there. That looks good. So now if we have our, set this to listen, we should hit enter here.
In this series, specifically in that search and destroy. Both these teams kind of sitting middle of the pack a little bit, have felt a little bit.
Okay, that's not working again. Let's close this out.
Number one, number two, hardpoint in control team. It's just been the kind of the awakening of the SMG.
Come back.
Different beasts during the stage.
That's 3 of the 3 reps, right? Yeah, that's pretty good then.
Oh my gosh.
Also played extremely well throughout this switch, and so you go back to his number one spot that he's had for years. And these guys,
wait, I didn't do the. Oh gosh.
Early, and having just seen LAP lose right there, I think that answers the question. It's still
I'm just gonna type it out because I don't know why. What's happening right now.
Let's talk a little bit about this squad from up north. It's not just Estrill. Gio is putting down huge numbers. You saw Paul X be a difference maker. But truly, if you're looking at this team, I think all eyes need to be on Nero. I like that.
I think that's a good shout because he's kind of that leading force when it comes to this Minnesota Rocket team.
All right, so we're gonna go.
So much pressure off the rest of his teammates, but there's a couple of issues for Minnesota Rockets right now. They haven't lost a hard win in a hot minute. They're on a 5-loss streak, and that and their search and destroy kind of the same story.
Oh, come on, Devin.
Really got to win versus the Vancouver Surge, but lacking some consistency when it comes to Minnesota Rockets.
Let's take a look at what happened last time these two teams met. It was over a month ago.
10. Try this again. 10.10.189.192 on port 8087. All right. Now we'll go here. All of that looks good. That doesn't. Okay. So now we hit enter. Oh my gosh.
Well, no, not a one-sided fight. For these two players to square up, I think they're going to be getting after it. And I think across all game modes, we're expecting an incredibly high level of production. I think each Israel brings his A game. They still have the advantage. It's really about the supporting cast from Minnesota.
Oh, that's right. I'm dumb again. Because it said before that it couldn't be that it had to be localhost 8087. So the localhost had to have it, right? Right? Localhost 8087/admin. Why are we not cooperative? Why doesn't things want to work for me today?
merging with these teams because you have Atlanta facing one side that's one of the deepest map pools in the league, and Minnesota Rock on the other that really doesn't count.
Mm-hmm.
For the side of Minnesota Rock, they're sitting at 1-4 on red card and 1-5 on mark point for Detroit. They are happy to see that Hacienda and that map 3 that might give them some opportunity, but they're going to be playing for win half this year.
If they can make it to that ball,
Mm-hmm.
that's all I'll say about this. We just saw like Appsec last series. Did it matter? It did not. Boston just did the impossible. Minnesota, I can see that take some good.
James, we want to remind everybody, don't chase your losses. But if you were, and Minnesota is the underdog here, the curse continues with upset after upset. How do they get it done in your eyes?
Again, fine. Literally, they're going to have to get to that all S&D with complexion and the pro ball functionality as well. Might be another one to slip through. I'm up the second half of the series. Going to the 16-point out on the protocol, you have faith in this one.
No, I was right the first time.
Yeah, they're literally the best ball.
I'm looking at it. I was right the first time. Download server. 10.10.189.192. Port 8087.
What was more likely to happen? Breeze beating LAPs or Rocker beating K's?
Oh my gosh, I probably would have told you Rocker beating Page just because Rocker likes to come out with a right hook sometimes, but
Historically, Rocker.
Okay, 1010, 144, 233, port 8087. Then we're telling it to go to the downloads, point to the download server, which would be HTTP 1010.189.8087, and then the ID. Get off of that. I mangled the request, y'all.
Not enough. I mean, not enough. More Call of Duty, we get to see it play better, at least for the major two finals, when all the resistance getting 7 around 11. But
I hate not using my stuff. All right, you won't need a flag to progress in this room. Go an extra mile. There's a way to use this SSRF to gain access to the site admin. Okay, so that's what I was trying to do, that part. Because I remember it saying something about localhost.
Very rare for them to let upsets slip through at all, but it's just impossible not to have that. When we're at Major 2, historically at Major 2, the last 2 majors. So, comfortable territory for these guys.
I'm gonna be honest with you. I'm probably not gonna do it because
I mean, that's the funny thing though.
I'm burnt out right now. I'm burnt out right now. But I'm gonna try one thing. Right? So we know we got that. All right. So let's get rid of this part. We know we're here. Localhost and ID, right? And it has to be localhost. And then that was port 8087. And that's an admin user. Right? And the ID. So now if we hit enter. We get a pi curl error, but it downloads. It downloaded. Do we need to separate that? No file selected. Okay, so we're close. What if we URL encode? What if we URL encode it? Stop with the Google the Google crap. Fantastic. Great. You use cookies. Good for you.
Texas, give a warm welcome to Atlanta Braves.
Oh my gosh. Percent encoding. So that is 23. So percent 23. Oh, look at that. We got it. So I was thinking of, this is the path I was going down before. I was going down this path. I was saying, oh, they said the admin thing had to be localhost, blah, 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 blah. So I was slowly going down that. So I deviated from the original path, which was right. But like I said, I mangled that request. So it was all over the place. And then I said, okay, well, then I switched it off. And then I said, oh, it's localhost. Then I checked the localhost thing and I worked through some of it. And I was like, okay, no. But then I looked back and I was like, no. I actually have to make it talk to my server for the SSRF. So, but we got it. We got it. So I'm gonna go ahead and I'm be honest with you. Like it was so. Things were just so stressful. I'm like dead ass. I think I'm done for today. I might just do some gaming or something. I don't know. Like I'm like dead ass just kind of messed me up. Oh my gosh. So I hope y'all are having a good weekend because, like I said, because for me it just kind of got stupid. So we'll come back Monday, and yeah, Ty, I don't know. Like I said, yeah. So we'll come back Monday and we'll go through the tools, see how many tools we can go through, and then yeah, we're done. We're done with this section because I don't think we said we're not doing any of this right now. We kind of covered most of this stuff, so we're gonna go. We're gonna finish up. When we finish up web hacking, we're gonna do offensive security tools because how we do because we will use Hydra and GoBuster or tools that are similar to GoBuster and Hydra. SQL Map is definitely the different shells is definitely one that's important too, and then from there we'll jump into our pen tester stuff. So yeah, I'm gonna drop off. Uh, Tomorrow we have a match. Hopefully, we'll have opponents to play against, and we'll be streaming. So check in live for that at 4:30. We'll probably do some stuff. We'll do few things afterwards, and then we'll also be streaming on Saturday. So go ahead. You guys have a good night, and I will talk to you guys later. Take care.
Do you have a reference?
Huh?
Do you have a reference?
Yeah, back there.
Okay.